I can determine the area of a large rectangle by using the distributive property. So we're going to be breaking apart our multiplication equation that we use to find the area. We're going to break apart one of those numbers and distribute it using this property. And this is going to be helpful when you get to 4th grade and you have really big arrays. Whenever you're able to break apart and see two smaller rectangles and find the area of both, you'll be able to add those two areas to find the combined area for the entire shape. So looking at this first example, we need to figure out all the different ways that we can write the equations for this one array. So just focus on this top section above this line. We have the original array, and I want to write the multiplication sentence that I would use to find the area. So I'm going to label my side links. I see that it is 4 squares high, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9 squares wide. So my multiplication sentence that I can use to solve for the area would be 4 times 9. And I can break apart one of these numbers using that distributive property. So I'm going to look at the picture down below to see which number they broke apart. I can see that they drew a line going vertically up and down. So if I were to draw that same line above, I'm going to run into that top number. They must have broken apart this 9. So let's look at the two areas that they have now. So I can see that I have 3 squares on one side of this line and 1, 2, 3, 4, 5, 6 squares on the other side of this line. So they must have broken up the 9 into 3 and 6. So I'm going to put those numbers inside of my parentheses. So again, they drew that vertical line splitting up the 9, and I have 3 squares to the left of it and 6 squares to the right of that line. So that's why I have 3 plus 6 inside the parentheses. I didn't break up the 4, so I still have the 4 on the outside of the parentheses. And now I can distribute that 4 to every number inside of the parentheses. And again, I like to use that story to help remember the order of the numbers and the symbols whenever I'm rewriting this equation. So I pretend that the number on the outside of the parentheses is Mr. Popular. So we're going to say 4 gets invited to 2 parties. He gets to go to 3's party and 6's party. So 4 is going to go over to 3's party first. So in the parentheses, I would write 4 times 3. And the reason why they're in parentheses is to kind of designate that this is one figure. And in my story, you can think of it as that's the house. So 4 is going to 3's party at their house, and they're doing the X dance while at the party. It's this new fad. It's all the craze. And then 4 is going to go add on to another party, and he's going to go to 6's house next. So in my second set of parentheses, I can write 4 times 6. And again, the X is in the middle because they're doing the X dance. That's also represent the two different arrays that I now have. So if you were to focus on just this blue part of the figure, I have 4 rows of 3, which is represented by the blue set of parentheses. And then if you look at the yellow-sided portion of this array, I have 4 rows of 6 squares, which is represented by the second set of parentheses. So now we can multiply the numbers inside of the parentheses to go further into our equation. So 4 times 3 equals 12. 4 times 6 equals 24. And again, I'm trying to combine the areas of both of these shapes. So we need to add 12 plus 24 is going to equal 36. And I can check myself by going and counting every single square and making sure that I do in fact have 36 square units. So let's look at this example. I have my original array, and I'm going to label those side links. 1, 2, 3, 4, 5, 6, 7 squares high, and 1, 2, 3, 4, 5, 6, 7, 8 squares wide. Looking at the array on the right-hand side, I can see that they split it up. They drew a vertical line. So I'm going to draw the same one on my first array. If I draw it straight up, I can see that they broke apart the 8. They ran right into it. So I want to write the multiplication sentence for the original array first. I could have solved this using 7 times 8. But if that's too big, I can use the distributive property to break apart this array into 2 smaller arrays. So let's break apart this 8 into 5 and 3. So I'm going to count the squares to the left of the line and then to the right of the line to see how they broke it apart. So inside these parentheses, I'm going to write 5 plus 3. And there's a plus sign inside of this set of parentheses to demonstrate that they broke up the 8 into 2 smaller add-ins. Because if I add 5 plus 3, it still equals 8, and I still have my original equation. It's not until I start distributing this 7 to every single number inside of the parentheses that my symbols kind of change up a little bit. So let's retell that story. So 7, since he's on the outside of the parentheses, he's Mr. Popular who's going to get invited to everybody's house party. So 7 goes to 5's house first. So inside these parentheses over here, I'm going to write 7 times 5. And they're doing the extents at this party. And then 7 is going to add on to the rest of his night by going to 3's house. So inside my second set of parentheses, I'm going to write 7 times 3. Again, they're in parentheses because they're at their house and they're doing the extents. Now I can multiply the numbers inside both sets of parentheses. 7 times 5 equals 35. 7 times 3 equals 21. And then I can add these two numbers together. I like to add using standard algorithm. So in some empty space, I'm going to write 35 plus 21. I'm adding because that's what my symbol tells me to do. 5 plus 1 equals 6. 3 plus 2 equals 5. So my area would be 56 square units. And again, I can check myself by going and counting every single square. And you may have some equations like this where they want you to figure out which equation matches the one being demonstrated by the array. So it wants us to label the side lengths first. So I have 3 squares on the left and 1, 2, 3, 4, 5 squares for the width. So I would normally solve this by using 3 times 5. I'm going to write that out to the side. But they have split up that 3. So if I trace that array right where they split it, I can see if they ran right into the 3, they must have split it into 2 and 1. So inside parentheses, I'm going to write 2 plus 1 times 5. And since 5 is outside of the parentheses, I'm going to distribute it to everything inside the parentheses. So 5 is going to go to 2's house party first. 5 times 2 is going to add on to the rest of his night and go to 1's house party next. 5 times 1. I'm going to see which equation down below matches. So this is where you've got to look at your symbols carefully. I wish you could see all the other options down below. I'm going to try and hold my mouse so you can see that B and D. So on letter A, see 1 times 5 plus 2 times 5, which matches the equation that I wrote over to the left. On letter B, I see 1 plus 5 plus 2 plus 5. I only see plus signs. So B is not going to be one of our answers. We can cross off B. C says 1 times 5 times 2 times 5. I don't see any addition symbols in that equation, so C we can roll out because of the fact they don't have the correct symbols. And D, 1 plus 5 times 2 times 5, again, they don't have the correct symbols. We need to have the multiplication symbol inside of the parentheses combined with that addition sign in the middle. So letter A is going to be our answer because it matches the one we have over on the right-hand side. Now, granted, they have 1 times 5 and I have 5 times 1, but that commutative property multiplication says it doesn't matter the order that you multiply in, you're going to get the same answer. So I have my multiplication symbols inside the parentheses. I have the addition symbol combining the 2 sets of parentheses, and I'm multiplying 1 times 5 and I'm multiplying 2 times 5. So A would be our answer. So look for those symbols to help you find a matching equation. On this example, it says Alyssa solved 17 times 4 by breaking apart one number. What number belongs in the blank? So my original equation had the number 17 and 4. Looking at this new equation down below, do you see 17 anywhere? No. So that automatically clues me that they must have broken apart that 17. Can you figure out which numbers they broke apart the 17 into, looking at the numbers in this equation down below? So I see the numbers 10 and 7. If I were to add those two numbers together, 10 plus 7, it equals 17. And remember, you only break apart one number when you're using the distributive property. So they broke apart 17. They must have left 4 alone. So 4 is going to be that number that it gets distributed to everything inside the parentheses. So since I only have 4 once in this new equation down below, I must be missing a 4 in the second set of parentheses. So let me show this a different way. So if my original problem was 17 times 4, they broke apart the 17 into 10 and 7. So 4 is going to get distributed to everything inside of the parentheses. So 4 times 10 plus 4 times 7. So notice how the number 4 is being repeated in both sets of parentheses because we didn't break it apart. Let's look at this problem now. So Trevor solved 4 times 7 by breaking apart one of the numbers as shown below. What number belongs in the blank? So again, my original equation was 4 times 7. Let's look for 4 in this new set of equations. I see 4 being repeated. Now let's see, do we see 7 in this new equation down below? No. So they must have broken apart the 7 into 5 plus something. So what could they have broken that 7 into? 5 plus what equals 7? If you said 2, you were correct. So I want to show this equation a different way. So if my original equation was 4 times 7, they must have broken apart the 7 into 5 plus 2. And they're going to distribute that 4 to everything inside the parentheses. So 4 is going to go to the X dance at 5's house party. He's going to add on to his night, and then 4 is going to go do the X dance at 2's house party. So 4 times 5 plus 4 times 2. So if you look at your original equation and you see a number being repeated, they must have left that number alone. And if you don't see your number from your original equation, they must have broken that number apart. So I saw the 5, and I had to figure out, well, 5 plus what equals 7?